not in many other places. My advice, wire up your home and stay there. And I'm sure that many of you have it a little bit the same way as me, because if you have a production facility and you have wires, you kind of know that it's working. So why should you bother with wireless communication in the first place? And actually, there's a couple of good reasons for that. So one reason is that if we look at the development we have gone through when it comes to industrial production, we can see that if we go back 200 years and I needed a new shirt, I would go to my tailor, he would take my measurements, and then he would make a shirt specifically for me. And this is what we call craft production. So there was a very, very low volume per product, usually only one volume, only one product per production. And also we had a huge product variety. Then we go forward to around 100 years ago, here illustrated by the Ford Motor Company. So now we have mass production. So with mass production, we were able to produce cars that were so cheap that ordinary people could actually afford them. But what happened was that the product variety became very small because all the cars were exactly the same. And at the same time, we had a huge volume per product. Then things kind of evolved, and people realized that they didn't want exactly the same products as the neighbors. So then we came into this era of mass customization. So now all of a sudden you could get the car in different colors, with sunroof, with memory seats on the driver's side, on the passenger side, and different fittings to match your car. So this is what we call mass customization. So now what happens is that the product variety starts to go up and the volume per product goes down a little bit. And now we are in this era called personalized production. So we see that all the time we have shorter and shorter production cycles. We have shorter and shorter life cycles of our products, and also we see that more and more products can be personalized. So once again, we see that the product variety goes up and the volume per product goes down. So if we look at one example of a typical production line, we see that the production line is really optimized for producing exactly only one product. So not very much flexibility here. And this, of course, is the concept that we have defined with the mass customization. But as we move forward and we want to achieve Industry 4.0, we realize that we need to fully digitalize our production facility. We also need full flexibility. And what this brings us is that both the products are moving around by themselves in the factory. We have mobile machines. And then, of course, everything is integrated with the IT system so that you can have a fully automated, flexible production. And actually, it's very, very hard. I would say it's impossible to achieve Industry 4.0 without wireless communication. So this is one reason why we need wireless communication in our production system. Another reason has to do with the technology side. So if we look at the wired interface cost, we see that in the beginning of a technology cycle, the cost of an interface is quite high, but then over time, as the silicon price comes down, we have cheaper and cheaper price for the interface, but then at the end you have a cost for the connectors and magnetics and IP rating and cabling and so on. So there's a limit to how cheap you can make the interface of wired communication. And this is a little bit different when we look at wireless communication. So in the beginning, wireless communication is usually more expensive than wired communication. But then as the price of silicon comes down and the technology matures, we can actually have a much cheaper wireless interface than we can have a wired interface. So of course, if we look at the 5G, the radio chipsets are very expensive at the moment. But if we look at another technology like Bluetooth, for example, we see already now that a Bluetooth interface is a lot cheaper than a wired interface. So if we look at the factories today, we see a number of different use cases. So one is that if we have a PLC connecting some to a machine or a sensor actuator, we sometimes want to have this as a wireless connection. So this is one possibility. We also see that increasingly the machines that come with a HMI they have this replaced with a wireless connection, and then you bring your smartphone or your tablet instead. We also have, of course, all the autonomous guided vehicles coming into the factories, basically in order to integrate factory automation and material handling. Then in the factories, we see a lot of things moving. So we have things that rotate, we have things that move back and forth. And for this, we use drag chains and slip rings. But quite often, this can be implemented both more reliably and also cheaper by using wireless technology. Then we have sensors, quite often for collecting parameters from the production. So it's good to put in the sensors, of course, but in order to have a cost-effective communication, it makes sense to use wireless communication. Then increasingly, we see a lot of mobile machines in the factory. So the example here is a CNC machine. And previously, this CNC machine was operated by a person. But in this example, here you have a collaborative robot putting in the material into the machine. And typically these kind of machines, they are mobile, so they also need wireless connection. Then we have cloud connectivity, typically in order to provide remote access for machine builders. And then we see that a lot of the tools in the factories are becoming wireless or battery operated, but you still need to have the connection to the IT systems in order to report torque and other parameters. So this is some of the use cases we see in the factories today. And the technology of choice is Wi-Fi. But with Wi-Fi, we get all the usual wireless communication challenges. So one example is that we need the signals to go from A to B. So of course, it's better to have line of sight. If we don't have line of sight, we need to rely on reflections and refractions. But even if we have line of sight, there's something called the Fresnel zone. So we need to make sure to have some extra space in case we have a wireless connection relying on line of sight. The other aspect is that the wireless technologies like Wi-Fi is actually using the same frequencies as a lot of other technologies. So in the same frequency band, we have Bluetooth, we have 802.15.4, which is used for Zigbee and wireless HART, but we also have proximity sensors. We have glue machines and other machines in the factories using the same radio spectrum. But luckily, since it's usually one organization owning the factory, we can do frequency planning. And part of this frequency planning is commonly we put the wireless LAN on the 5 gigahertz band, and then we reserve the 2.4 gigahertz band to other technologies. Then we also have another way of combating this wireless coexistence, and that is to use a special antenna installation. So for example, if we have a conveyor belt, we can use leaky cables, which provide basically a distributed antenna. So we have exactly for this conveyor belt a good Wi-Fi connection. And then, for example, with Bluetooth, one way of solving the coexisting problem is that Bluetooth uses adaptive frequency hopping. So it means that the Bluetooth will search out the best frequency by itself. So there's a lot of work to get wireless technology to work in our factories, but in the end, it's very, very hard to live without it. But still, when we have facilities that are very large, and the example I bring up here is the Daimler factory in Sindelfingen, so it's 3 million square meters big. And when we try to provide good Wi-Fi coverage in a facility that is this big, and at the same time, we deploy more and more mobile machines using wireless technology, it becomes really, really hard to maintain reliable communication on the Wi-Fi systems. And this is why a lot of our customers are now announcing that they are installing 5G systems in order to evaluate if this is something that can be used in order to achieve the production systems of the future. So if you look a little bit closer at 5G, it's actually a number of different services. We have what is called enhanced mobile broadband. So this is what gives you fast internet for the home or for your smartphone. So it's more than 10 gigabits per second in download speed, typically, and then it has a capacity increase of 10,000 compared to LTE. We also have machine-machine type communication. So this is the sensor type of devices. So they can run 10 years on a battery. It has very, very low cost, and then we can have a huge density per square kilometer. And then what we are really looking for in factory automation is what we call ultra-reliable low latency communications. So this is where we can achieve less than 1 millisecond radio latency, and also we can have an availability of more than 99.999%. So this is very, very low latency and very, very reliable communication for factory automation. Other question is, if I have a factory, should I choose Wi-Fi or Wi-Fi 6, or should I go with 5G? And actually, there are some fundamental differences. One difference is the way that we provide handovers in the different systems. So if we have a Wi-Fi or wireless LAN system, and we have a mobile machine, then the mobile machine will connect to one access point. And then as it moves along, the signal strength from that access point will become lower and lower. And then at one stage, it will make the decision to move to another access point. And when it moves from one access point to another, there's a small gap in the communication. And if you have a Wi-Fi system in your home, this can be several minutes sometimes. But if you use something called 802.11r fast roaming, you can get this handover to come down to around 30 to 50 milliseconds. If we look at 5G, on the other hand, there's a possibility that a mobile machine on 5G can actually connect to several base stations at the same time. So in this example here, we have an ADV. It connects to the first base station and to the second base station. And then as it moves along, it will have a smaller signal strength from the first base station. Then it will make another connection to a third base station, and then it will drop the connection to the first base station. So it means that with 5G, we do not have these interruptions when you go from one base station to another. And also, of course, this kind of idea of having multiple connections to multiple base stations give a lot more reliable connections. Another aspect of 5G is 5G New Radio. So with 5G New Radio, we have something called the Massive MIMO. So it means that if you look at a typical 3G or 4G base station, you often have antennas that cover 120 degrees. But with 5G, you can actually have smart antennas. So it means that the base station can make a beam specifically for each device connected to the base station. And this, of course, gives a lot larger capacity. And this is part of the reason why you can see this 10,000 times capacity increase compared to today's LTE. Aspect is low latency. So normally, when you send data from a device to the base station, we will need to send a short message to the base station, requesting the permission to send, and then the base station will tell us when to send the data, and then we send the data. But with 5G New Radio, we can have something called grant-free data configuration. So it means that the device can just send the data whenever it has data to send. And this is actually part of this reduction in latency we see on 5G compared to today's LTE. A third aspect is the frequencies that we use for 5G and Wi-Fi. So with 5G, you have different options. You can set up your own private 5G network using unlicensed frequency bands. So this will be the same frequency bands that you also use for Wi-Fi and Bluetooth. So typically this will be in the 5 gigahertz range, or maybe if it's in the US, it will be the 6 gigahertz frequency range. So this is, of course, very easy, but you have the same challenges with interference as you have on the Wi-Fi systems. The other option is that you set up a private network in the license band, and in some countries like Germany or the UK or the US, you can get a radio license directly from the government. In other countries, one option is to get a sub-license from a cellular operator. So once you have this license, you can operate your own private 5G network in your factory using dedicated frequency bands that's not allocated to anybody else. And this is something that's ongoing worldwide, but what we see is that typically we have frequencies available in the 3.5 gigahertz band, suitable for private networks, and also in the future we will see millimeter wave in the factories. And then the third option is that we can have semi-private networks. So this means that we will use a public network, but we will have our own private part of the public network. So it's something that works for the end user like a private network, but it's actually driven more cost effectively as part of a public network. So with HMS and also myself, we have been through this journey the last 4 or 5 years. And initially, we have done a lot of presentations. So this is from Mobile World Congress, Hannover, Shanghai, Chicago, Aachen, Singapore. And also we have been doing a lot of demonstrations to get interaction and discussions with our customers. But now we're moving into another phase where we start to see commercial projects being launched. And what we see at the moment is that there's really 3 major drivers for putting in a private 5G system in a factory. So one use case is centered around closed loop control. So this is typically the automation engineers. They see that they have factories running today and everything is wired, and they are looking to replace the wired communication systems, typically industrial Ethernet, with the 5G communication. Then we have the mobile robots. So here we have robots that move around in the factory, and these need wireless communication. So here the question is not so much whether you need wireless communication or not. It is if you can get a more reliable connection by using 5G. And then we have the massive sensor networks, where we have digitalization companies that go into the factories. They connect to as many machines as they can, and then they put up sensors everywhere. And then in order to bring down the wiring cost, they use 5G systems to bring the data from the machines up to the IT systems. And then once in the IT systems, you run AI algorithms in order to optimize your production system. So I think now I will show you a small demo of one project we were part of earlier this year. And this demo is about fence inspection at a airport in Denmark called Hans Christian Andersen Airport.
Hver dag bliver der inspiceret hegn rundt om infrastruktur verden over. Det er på grund af lovkrav om, at man skal sikre sig, at hegnet er intakt. Vi har derfor undersøgt sammen med Launch Technology, om man kan automatisere den her tidskrævende proces. Ved at lade en robot gå langs hegnet og kontinuerligt optage billeder og analysere billederne, så kan vi så få et indblik i, om hegnet skulle være defekt. Til at analysere billederne, der anvender vi kunstig intelligens og et regelsæt, vi har sat op for, hvordan pigtråden ser ud, hvis den er intakt.
I projektet her har vi anvendt vores terrængående spotrobot, og vi har i samme forbindelse samarbejdet med TDC for at se, om vi kan udvide robottens rækkevidde over 5G-netværket. Lige nu står vi oppe i kontroltårnet, hvor vi kan se hele vejen rundt. Så er der forbindelse, så går vi første gang på 5G.
So we were part of this project as the company supplying the devices on the robot and also on the control tower. And I think this project is a quite good example of what you can achieve with 5G. And also to summarize a lot of these proof of concepts and demos that we have been part of, we can see that sometimes for large facilities, it makes a lot more sense to use cellular technology than to use Wi-Fi. So for example, with the airport, it's very, very hard to achieve Wi-Fi coverage on an airport, but it's quite a lot easier to do that with 5G. Another part is that for many projects, we see that there's a wireless connection that's used for process control. So in the example with the robot dog, we see that the dog has a motion control system internally. So this is what controls the legs and so on. And of course, for motion control, you have very, very tight timing requirements. but then at the same time you have a connection from the control system on the robot dog to a central location, in this case the control tower. And here you actually have a lot less stringent timing requirements as compared to the motion control system. Also, what should be observed here is that often the throughput required for control loop is quite low. It's usually less than 1 megabits per second. But what is the challenge here really when it comes to wireless communication is that we have a strong requirement for reliability in order to meet real-time deadlines with virtually no packet loss. So this is the strong challenge for both Wi-Fi and also for 5G to achieve this. And at the same time, we see many projects where we have a wireless connection for carrying video. So quite often you have mobile machines and you put video cameras, 2D cameras or 3D cameras on the mobile machines. And then the idea is that you should stream this data up to the some kind of central IT system where you can then do the artificial intelligence and image recognition and so on in order to analyze the video stream. But then the challenge here is that actually we saw previously that 5G can provide up to 10 gigabits per second. But when we talk about these speeds, it's actually the download speed. If we consider the upload speed of 5G, it's a lot lower, and usually for the private 5G systems, the uplink speed is a lot less than 100 megabits per second. So this is another challenge that we then have with the video connection, is that it's hard to get enough 5G uplink throughput. So often in these projects, you end up in a situation where you have a central AI system, and then you have some kind of local AI system close to the camera that does pre-processing before we send the data to the central system. So to finalize, I'd like to ask, is 5G the answer to Industry 4.0 and smart manufacturing? And actually, I think that from a technical perspective, 5G is superior to all the other technologies. But there's also some challenges that we need to solve with 5G with regards to regulatory aspects. So not in all countries do we have the possibility to have private 5G licenses. There's also a challenge to build up the ecosystem that we see in the automation world today, where we have device manufacturers, we have machine OEMs, we have machine builders, we have system integrators, we have the factory owners and so on. So this ecosystem is not existent yet when it comes to 5G. And then of course there's all the other technologies, but at least I think from a technical perspective, 5G is very, very suitable for the future of factory automation.
Okay, Jens, thank you very much for your presentation, for your interesting presentation. Now we have another presentation from Mr. Adrian Skras. So if you want to share your screen, please. And start when you wish.
Hopefully you're seeing my screen in full view. Yeah?
Yeah, we are.
Good, good, thank you. And thank you very much, Jens, for setting the background, because you've covered some of the work that I'm going to cover, of course, and I will just embellish on some of the things that you already said. First of all, I should explain I'm not a process control man at all. I do know something about 5G, but I'm not an expert in manufacturing processes. And that's, I don't think I need to be an expert in factory processes to get across the messages I'm trying to give here. As we go through the presentation, you will find a lot of references. The references are to 3GPP specifications. So if any of the slides ring a particular note with you, in your own time, you can go to the 3GPP website and just download the reference document, and you can read that at your leisure. There's no passwords, it's all free of charge. You can just go and have a look. So what I'm trying to do really here is give like a whistle-stop tour, a landscape of what's happening in 5G, and in particular how certain industries are starting to become very interested in 5G. And then by doing so, maybe you will see some spark of interest there from a manufacturing point of view, because some of the industries I'm going to talk about have very similar demands and requirements that you have. So first of all, the famous triangle, which Jens has also presented. I make no apology for repeating this triangle again, because it's always important to remember that 5G is trying to solve these three major use case families. So enhanced mobile broadband on the top, massive machine type communications bottom left, and ultra reliable and low latency communications bottom right. And depending on your use or your need, you might fit anywhere within this triangle. So from a standardization point of view, we try and meet the extremes of the triangle, but at the same time understand that there are use cases that lie between those extremes. It's also important to understand that it's not just about mobile broadband, and for citizens, 5G is just the next version of their mobile phone. And that's absolutely fine, because that is a valid business model. Operators know how to sell mobile broadband to end users. Yes?
Yeah, excuse me. I think we're only seeing your first page, not the next slides.
It's not true. Okay, can you see now?
We're still seeing the first one.
1 second then.
The title.
Transitioning now?
Yeah, now we can see the,
Okay.
This is moving now.
Okay, thank you. Then I'll pick up just from here. I was explaining that mobile broadband is important. It's important because it's the first use case that's being delivered to end users. But so are the other two use case families. And when we look at industrial use, it's quite likely that you will actually want all three of those use case families in what you're trying to achieve. So I'm not just going to focus on any particular one of those use cases. Looking at the standardization activity itself, there is a very clear focus on 5G within the body 3GPP that is setting the standards. The work package was first established in 2015. It was a very large piece of work, so we set about this in two phases, phase 1 and phase 2, which translate to 3GPP release 15 and 3GPP release 16. Those releases are both completed. They have been submitted to the ITU, and the ITU have confirmed that they meet the requirements of IMT 2020. So the groundwork has all been done for 5G in the first and second phases, and it's on the basis of those releases 15 and 16 that we're now seeing commercial deployment. And if we have a look and see the amount of deployment, it's quite an interesting story. The slide on the screen, the picture on the screen shows that back in 2017, when this graph was produced, we didn't expect to see 5G being commercially launched really until 2021, and then slowly picking up in 2022 or 2023 and onwards. What's happened in reality is that right now we have 163 commercial 5G networks already launched in 64 countries. So the rate of uptake far exceeds what we expected. It's much quicker than we expected. Though I think if we look at the 2025 block on that graph, and we match that with the latest estimates from the Global Mobile Suppliers Association, we're looking at 1.8 billion 5G connections by 2025. So that seems to sort of align. So in summary, then, we're seeing 5G deployments at a much greater rate than was first predicted. Where are we heading next? If we look at the standardization work, we are currently engaged in releases 17 and releases 18. That work really can be divided into two blocks. On the left-hand side of the screen, you can see that we're expanding the standards to encompass more industry use cases. So we're looking at smart energy, health, maritime, asset tracking, factory automation, wearables. So expanding the way in which 5G can be deployed in different scenarios. And on the right-hand screen, the development of 5G capabilities, which will help us to satisfy those use case requirements. And here we're looking at non-public networks, non-terrestrial networks, time-sensitive networks, use of extended reality, coverage enhancements, positioning accuracy, reduced capability. These are just some of the examples of what you will expect to see then in the coming releases. In terms of when you will see those new releases, just so that you can understand how progress is going, we have been challenged by the pandemic. That's slowed down the rate of work for sure. All of our physical meetings are now virtual meetings. That's the same for everything, I guess, these days. And that has challenged us in terms of keeping our schedule. So we have rescheduled release 17, which will now be complete as far as stage 3 definition is concerned by March next year. So that package of work is already well understood, it's underway, it will be completed by March next year, and it's too late for new work to be put into that release. So no new pieces of work will go into release 17 that is not already contained therein, which means that release 18 is the next big package of work that you can influence if you want to have your requirements captured. And to do that, we have a radio workshop which is taking place next week to start looking at setting the agenda from a radio point of view for release 18. Then we have an architectural workshop in September to look at service capabilities for release 18. And then by December this year, we will actually draw up the agenda of what release 18 will contain. So that's the end point, if you like. If you want to have any of your requirements captured in the standard, then the next real opportunity to do that is release 18, which means you need to get yourself on the agenda before December this year. Interesting that already, although we are at the early stages of 5G, we've decided that there will be an evolution of the branding. There will be something called 5G Advanced. And that is the name that we've decided we will give release 18. And I think this is indicative that release 18 is not going to be a small set of nice to have features. It's actually going to contain some very significant pieces of work which will merit having this new identity 5G Advanced. Now, traditionally, generations tend to last roughly 10 years in their development. So 2020 was the release of 5G. It's quite likely that round about 2030 we'll be talking about 6G. In fact, we're already talking about 6G now, but in terms of completion of standards, which means that by the midpoint we will have this new definition then called 5G Advanced. Jens mentioned something about radio allocation. I'm not expecting you to read that table on the screen. It's only there to illustrate the fact that we have many bands in which 5G has been specified. And this illustrates the point. In fact, there are more than 50 bands in that table, which is why you can't read it. And of course, that's just the unique bands. And then there are aggregations of bands where you connect 2 or 3 of these bands together to give you added capacity. The point I'm trying to make here is that as a standards body, we make no judgment on frequency bands. If there is a determined use to have a band specified, then we will specify that band. It doesn't mean that band is available universally, but it means that the specifications have been adapted to enable the use of those bands. And as Jens has already explained, there is also the capability of using 5G in unlicensed bands. Until very recently, that was only possible by having an anchor within a licensed band. So typically you would have a LTE anchor to which you would then aggregate unlicensed spectrum. What's happened in recent times is that we have specified the use of unlicensed spectrum in standalone mode for NR. This means that 5G can be deployed, for example, in the Wi-Fi bands, if you have regulatory permission to do that. Of course, there is no intention here to cannibalize Wi-Fi, and there has been some very good work done to ensure that where you do use 5G in unlicensed bands that are already occupied by other services, there is a good neighbourly behaviour to make sure that you don't just render other users of that band inoperable. Something else which is a significant change with 5G is that for the first time we have a non-terrestrial component, an integrated non-terrestrial component. Now, we had 3G satellite, we had 4G satellite. They really weren't very successful because they were standardized as an add-on, a standalone separate system, if you like, which was not integrated into the system design. So for the first time now in 5G, we actually have a fully integrated design where a 5G device may start its session on a terrestrial network. It may be handed over to a non-terrestrial network and back again. This is because the radio path is identical. It's the same radio used for both the terrestrial and the non-terrestrial networks. If you want to understand more about this, I've given you the reference on the screen. Surrey University in the United Kingdom have actually demonstrated handover between terrestrial and non-terrestrial, maintaining a voice call. Now, you might think, well, so what? But if you're really trying to get global coverage, if you're trying to cover parts of the planet which are not cost effectively covered by terrestrial networks, then this really is a game changer. It also means that for things like public safety, where you have disasters to cover, you can do that in a much more effective means. It also means that if you're trying to deliver services that require true global coverage, and we'll come to one of those later, if you want to cover oceans as well as land masses and deserts, then this really opens up the way for some quite interesting service concepts. So again, from my point of view, I think this is one of the game changers, the non-terrestrial network integrated approach, which we now have in 5G. Jens already spoke about non-public networks. Again, I do think this is one of the game changers. Not just the fact that we have public and non-public approaches, but that hybrid approach in the middle, which Jens explained. It may be for large manufacturing bases that they actually want to have a purely private approach and manage everything on their own. That's perfectly fine. Maybe they decide that it's better to use an already existing public network operator to provide some of those services. And again, I've given you the reference here if you want to go away and learn more about it. I think at least for the use cases you're trying to solve, this is very relevant, and we're seeing a lot of interest now from manufacturers, manufacturing campuses who are looking to see what is the sweet spot. What is the sweet spot between being fully private, being fully public, or that hybrid in between. So I would commend that technical report, and you should go away and read it. But everything I've said so far is useless if you don't have coverage. 5G is hopeless if you don't have 5G coverage. And whilst satellites is a very good way to try and extend your coverage, we believe there are also things you can do to the radio itself to improve coverage by fine-tuning the design of 5G NR. And this again is quite interesting for you people, I think, because it's not just about outdoor coverage, but it's a study into how can we improve indoor coverage. Now, it's widely known that if you're trying to use a metal warehouse which has moving robots and you have divided workshop floors, coverage can be quite tricky. So this study, which you can see on the screen there with the 38830, is very interesting, looking to see how with some quite clever radio techniques you can actually improve the coverage you will get from standard 5G radio. So again, it's something I think you might be interested in. Something else which I'm sure is of interest to you is high precision positioning. Now positioning, if we were talking about positioning a few years ago, we were talking about trying to locate devices within say 50 or 100 meters accuracy. That was typically to meet regulatory requirements. Most countries have requirements on positioning, really for public safety. So if you make an emergency call, that you should, by the use of the network, determine within a reasonable accuracy where that call is coming from. Well, if we translate that to what's happening in 5G, we're now taking that capability down to sort of centimetre accuracy. And again, for locating robots in factories, this sort of thing, the illustration on the screen is locating trains. Really adds quite an interesting capability if you are able to do location down to a few centimetres. It's really not simple, but the study which is on the screen here, if you go away and read that, you'll see what's being considered to actually achieve this accuracy, knowing that it's not just about providing high accuracy, but providing high accuracy in a very small amount of time, because the device that requires the positioning may be traveling at 20 or 30 kilometers an hour, for example, in a factory environment. So it's not just about accuracy, it's about speed and reliability and dependability of delivering that information. So again, an interesting function that I think you might do well to go away and look at. Likewise, many of the use cases we're trying to solve are looking at either augmented reality or virtual reality. Some are looking at mixed reality. We're studying the use of extended reality, which is the combination of all of those aforementioned reality mechanisms. I think it's quite obvious that in manufacturing environments, this could really be quite a useful addition to your portfolio. Again, it's not simple. We're really trying to grapple with the complexities of these different types of reality, understanding that whatever we specify will probably end up in multiple form factors. They could be wearable devices like smart visors, for example, in a factory environment. They could be in cameras. So, you know, when you start designing these things from the root up, you really have to try and envisage, you know, how will this be deployed in the end game? And we understand that there'll be multiple ways in which extended reality could be used. We just need to make sure that the standard is flexible enough to satisfy those different use cases. Something which is interesting, although it's not directly addressing your particular use case, but an area where they have very similar requirements is in smart energy. So if we look at the way the electricity is generated, transmitted and distributed, and even consumed, there are great opportunities here for 5G to provide much better performance than the incumbent systems. In a similar way, these power companies are using rather bespoke, rather old-fashioned radio mechanisms, control mechanisms. They're looking to replace them, and they're looking at 5G as a candidate to do that. It would be wrong if I was to say that decisions have been made, but at least the early study that we've done in this study on the screen shows that the use case requirements can largely be met by 5G in terms of the dependability, reliability, the speed and overall performance of 5G. This is a very difficult sector to meet if you're talking about controlling substations and responding to lightning surges. You're talking about very, very fast responses. And again, an interesting study into whether or not 5G would be a better solution than the solutions they currently have. So I think it's very much related to the sort of debate you're having within a sort of a smart manufacturing environment. Also building on the smart energy, if you look at it from a consumer point of view, smart meters appearing in most cities and towns now. They're all fine, but if you take this to the end point, you're getting near the sort of massive connectivity that Jens was talking about when in his opening slide, where you have something like 1 million devices per square kilometre. Now, in a very complex factory automation environment, I guess you could also be approaching massive connectivity if you add together the number of sensors and transmitters that you might have in a large manufacturing environment. So there have been dedicated studies to look at the complexity of having massive connectivity. You might want to actually address all of the devices in one go, group addressing at least subsets of devices. So you need to have a way to talk to the devices as a group. On the other hand, you don't want all of those devices to start transmitting at the same point in time, because if that was to happen, you know, you would really overload the network. So you need to have random spreading start transmit times for devices and sensors. And again, whilst this was really looking at things like electricity meters, I think it's the same concept if you're looking at massive sensoring within, say, a manufacturing environment. It's the same problems that are being addressed. But so far, I've really been talking about high capability, high performance, high reliability, low latency, and there is a whole design class that is actually the complete opposite end of the scheme, the what we call reduced capability. So if you have something that are just sensors, they don't need to have the full radio stack because that's going to be expensive. It will add weight and size to the device itself. So this study, which is ongoing right now, is looking to see, well, how can we strip down 5G to its basic forms so that you get all the bits that you need to have, but you don't have all of the baggage that you don't need to have. And here we're thinking really of industrial sensors, things like wearables, watches, that sort of thing. The study is ongoing right now, but you know, again, I can see quite interesting use cases for a low performance version of 5G, where cost, weight, power consumption are the prerequisites rather than you know, full-blown performance. So something you might want to go away and have a look at. In a similar vein, asset tracking. The illustration I've shown here is containers on a ship. That's an obvious use case where those containers may start their life in a port in South Africa and end up somewhere in the middle of Denmark, you know, in a farm. And you always want to know where that container is at any point in time. The illustration on the screen just shows how the containers are aggregated on the bridge of the ship. The ship then relays that information via satellite so that the owners of the assets can always know where those assets are. And the assets could be a high cost vegetable like asparagus, for example, and maybe you've got a gas sensor in the container, so you can already know whether or not the product's in good condition before it arrives in the port. It could be something like a very expensive piece of medical apparatus. It could be the machines that you have in your factory environment. And of course, I'm sure you have very expensive machines, and it's important to track those assets. And the asset tracking capability, again, is something that has really widespread capabilities. And again, I'd recommend you go and have a look at that if you're interested. Looking at the health sector, again, I see some parallels with manufacturing. You might find that strange, but I think you'll understand why in a minute. The health sector is extremely interested in 5G because they see this as a way to save money and to improve patient care. So at the moment, the expenditure on health is huge. Health systems tend to be based around patients going to hospital to be assessed and treated. There is a big push now to try and get that preventative care back out to remote stations so that you haven't got your hospitals and waiting rooms full of, you know, patients who've travelled quite some distance to come to be analysed and be checked. So for sort of chronic care, this can all be done remotely, and even for critical care, this can be done remotely, improving the experience for the patient and reducing the cost. If I had more time, I'd explain to you some very, very fascinating hospital trials that have been done using this in France and how they've really proven the use case for 5G in medical services. And in fact, it's that medical profession who've joined with us to write this report, which again, an interesting piece of work if you want to go and read it. If you're interested in things like remote surgery, robotic surgery, I must say I was a skeptic a few years ago. You know, if you said to me that you're going to have open heart surgery and it's going to be performed by a robot or it's going to be performed over a 5G radio link, you know, I wasn't actually convinced at the time. If you talk to the medical profession now, they are convinced, and they've demonstrated how they can really improve the reliability of surgery just by using 5G connected robots and by having the capability of bringing medical experts from the other side of the world to join the operation at the most critical point, where they just need that person to maybe take over the gloves the haptic gloves and actually perform the delicate part of an operation. Again, I say I was rather skeptical about this. The medical profession are very excited about it. If you are interested, I can point to you to some hospitals that are ongoing trials right now on the use of 5G connected operating theatres. Then to something a little closer to your hearts, perhaps 5G for control applications in vertical domains. You'll see this is a Release 18 study, so this is not destined to be published in the immediate future, but this is something that you probably want to go and have a look at. It's looking how you can have CyberCav control applications running over 5G networks, so directly relevant to your particular use case. The study is actually being led by a CyberCav expert and is gathering together similar like-minded people who are now looking at the capabilities and defining how this could actually work in a 5G environment. It would be wrong for me not to mention security, because with every one of the use cases I've mentioned above, the communities, when first looking at 5G, always say, well, is it going to be secure? It's the basic question that everybody asks. Of course, security work is never finished. It's an ongoing activity. Right now, the security profiles in 3GPP, that study was actually completed before we defined the new radio. So with 5G, security was actually at the beginning of the process rather than at the end. In previous releases, we've tended to design the radio, design the core network, and then say, well, how can we secure this now? In 5G, it was done the other way around. The security parameters were set before we started to design the radio and the core network. And that was done for very good reasons, because if you're working in the health environment that I've just mentioned, or if you're working in banking or finance, or even in the industrial applications as a whole, you want to be sure that your network is secure. And there is extensive work being done on security in general. There have been bespoke studies that have been done. I've mentioned the one here for the Industrial Internet of Things. There is a specific report there on how the needs of the industry IoT have been met by 5G. So again, I would commend that report to you. But what I would say is that, I often hear people believing that actually security is all about standards, and if the standards are good enough, you will be secure. And of course, that really isn't the case. Standards are a very good starting point, but they're by no means the end point. Because once you have good standards, you need to make sure that they're securely deployed with security in mind, and then operated with security in mind. And if we look at all of the examples we've seen recently of major security breakdowns, it tends to be that last point, is the way in which the networks are being operated. It's human error or malicious intervention that actually caused the secure breaches, rather than weakness in the security design. So something to bear in mind if security is your thing. We're delighted to have written some really good security standards, but you really have to take into account the way those standards are deployed and the way those deployments are operated. And only if we get all three of those aligned will we end up with the sort of security that we all want to see and have. So conclusions from my side then, we see many industry sectors demanding high availability, high reliability, low latency and secure communications. And from where I sit, 5G has been designed exactly to support that. So I think 5G is a great candidate if those are the sort of capabilities you're looking for. 5G has been designed explicitly for both licensed and unlicensed spectrum, and for use in both public and non-public network configurations. It's been designed with both terrestrial and non-terrestrial access in mind, and designed with an integrated component of both. It's also designed for massive connection capabilities. If you're looking at massive IoT, it's also designed to have a reduced capabilities where they may be appropriate. And then finally, as I sort of started really, 5G, it's being deployed much faster than we first predicted. And at least I think that it's going to revolutionize many industrial sectors, including those in the manufacturing sector. So I will leave it there. Thank you.
Thank you very much, Adrian. Very interesting presentation as well. So now the floor is open to any questions that the public may have.
I have one, if I may start, Patrice. The question is, I think, a little for both for Jens and Adrian. In your presentation, Jens, you listed the use case for industrial process control using 5G, and you mentioned PLC to I/O, HMI, AGV, cobots. But the example, of course, the demo with the dog around the robot around the airport was not so much demanding as PLC to I/O, not to mention safety. And then thank you also, Adrian, for the presentation. It seems to me that the features that will be delivered with release 17 will include significant features that will be necessary for actual process control. So of course that's a more specific debate, but can you elaborate on this? Should we wait for release 17 on the associated features? This means products by 2023-24 to be really able to connect sensors and, more important even, actuators on PLC using 5G.
Do you want to go first, Adrian?
Oh, you go first, Jens, and I'll pick up the second question.
Okay, sounds good. So I think that I'll try to answer your question, because now we have, or maybe I'm answering the second question. So I think like when we look at the use cases we have in the factories, there's so many use cases, and there's also a time perspective, and there's also a question of what it actually is that we want to achieve. Because now we can see that for around 30 years, we have been deploying factory automation, and parallel with this, we have been deploying automated warehouses. So when you walk into the factory today, then we see that all the machines have been automated, and we see that all the warehouses have been automated. But this doesn't mean that everything has been automated, because you still see that we have people carrying the material from the warehouse to the machines, and the finished products from the machines back to the warehouse. We also see that when we want the machine to produce something, we go to the IT system, we take out a production order, and then we type that order manually into the machine. So I think when we talk about Industry 4.0, we really want to automate all the use cases in factory automation that we have not automated so far. And this is really the connection of the machines to the IT system, and then it's the integration of the factory automation with material handling. So these are really the highly pressing things right here and right now. And for this, you don't actually need, and now I'm starting to answer part of Adrian's question. I apologize for this ahead. But in order to solve these use cases, we already have good capabilities in release 15. But of course, when you look into the future, we want to see use cases where we have two robots, they come in and then they do something together, and then you need a lot better features. And this is probably something that Adrian will give us in some of the future releases.
Well, thank you, Patrice. Actually, the question you ask about, do we go with release 17 or should we wait, is actually a really interesting question, and it's one that's frequently asked, because why not wait for 6G? Why do 5G when you can wait for 6G? That's the other end of the extreme. But I think what you need to understand is that in a body like 3GPP, work isn't done for you. So there is the fact that I've explained so many industry use cases is illustrative of the fact that there are many communities who are all bidding for the same agenda time in the standards committees. And it's hugely competitive. So if you want your piece of work to get to the front of the agenda, you have to lobby really hard. You have to make sure that as an industry, you're very much aligned, that when the debate takes place about what's going to be included in the next release, your community is there well represented and all the hands go up, and you say it's absolutely inconceivable that this work should be left to the next release, it should be in this release. So you can't sort of just sit back and wait. As an industry, you need to get engaged. You need to really understand what are the current capabilities that have been standardized, understand what are the critical things that are missing from that list that will prevent you from deployment, and then learn how you can influence the agenda and get that work done within the standards body. And this is where, in isolation, companies going to 3GPP may not be able to succeed, but where they have successfully got together with industry groupings like associations that help to sort of get the alignment of the industry, you then end up with a very, very solid position in a standards body, and you can influence what's happening. So in summary, you've got to know what the current status is, what's in the standards, what do you need that isn't in there, and how can you influence the standard to get that included. And also understand, and this is particularly valid for many of the new sectors that are coming to the mobile community, is that the work never stops. So once you get onto this sort of 5G train, you're not going to work for 2 or 3 years and the job's finished and everyone goes home. It's a continuous evolution stream. So this will your features will be constantly upgraded for many, many years to come, which means that you'll have to continue investing as the technology evolves over the next decade, which is a different model to the one you've been used to, which is where you spend a lot of money at the beginning. You then don't invest for 10 years and then you have to spend a lot of money again to upgrade. So if you look at things like trains, that's what trains do, isn't it? A train has a 30-year life. You spend a lot of money putting all the control systems in at the beginning of its life. 30 years later, it has to be changed because it's so out of date and old-fashioned anyway, and you've got no manufacturers left to repair it. So we're talking a very, very different sort of model for investment here. It's continuous investment of small amounts of money rather than forklift changes every 20 or 30 years.
Okay, any more questions? I have a question for Jens. Jens, you explained the 5G and other wireless technologies, and my question is, quite a simple one, but can you explain simply when 5G is the appropriate technology to be used in process control and when other technologies are more appropriate?
I think it's a very, very good question, and it's also a very, very hard one to answer. But I will try to make it. Make a simple answer to the question, because I think if you have a small facility, only a couple of machines, you would never, at least with the state of the technology today, you would never invest in a private 5G network. But if you have a larger facility, and for example, you have more than 100 ADVs, then all of a sudden it makes sense to start looking at having a 5G system, because the challenge of keeping the stable Wi-Fi connection to your 100 ADVs become so burdensome that it's okay to put down the investment to have your private 5G system. So this was a very, very simplified answer, and actually there's a lot of other aspects coming into it as well, like what kind of use cases you have, what kind of production are you using? Is it more, is your production very, very tailored, so you need the flexibility, or is it more mass-produced products and so on?
Okay, thank you.
Yeah, thank you.
I have one question for Adrian. You mentioned 6G, which can you give us a glimpse of what can we expect about 6G? What is different to 5G, and what is new in there for process control?
I actually had 6G slides in my presentation and I took them out because I knew I'd be overrunning if I got onto 6G. Actually, I think it's quite a fascinating situation we're in right now. When we transitioned from, when we first published the 4G standards, people started to talk about 5G and we were forbidden for even mentioning the phrase. I would have been sacked if I had put 5G in my slides just after we'd published the 4G standards. And yet here we are with 5G, standards just complete, and everyone's talking about 6G. All of the major operators and vendors have 6G position papers. I have a slide which lists all of the publicly available 6G vision papers. So already the world is looking to see where are we going to be around about 2028, 2030. So the timeline is sort of understood. There's a bit of a debate. Some parts of the world want to move to 6G quicker than others. So if we look at Korea, for example, they're looking at deployment by 2028 of 6G. If you look in Europe, we're really saying 2030 for 6G. But the miraculous thing is that we're talking about it and we've only just published 5G standards. What is also interesting is that, you know, it's fine to have the philosophical debate about 6G and when's it going to be available. But if you look in these position papers, they are very detailed, you know, they really are detailed, understanding of use cases that 5G cannot solve, which 6G should be able to solve. What I think is, for me, the real big ticket item, I think, in there is not going to be performance. For me, the big ticket item in 6G will be all about sustainability, because the way we're heading, we're trying to get more and more performance out of everything we do, out of our cars, out of our telecom systems. You know, everything is using more and more power. So we're desperately trying to reduce energy consumption because we know it's not sustainable. And I think if the vision we have of 5G in industrial scenarios and everybody starts to use 5G in their industrial processes, we will be under immense pressure to do this, consuming lower energy, much more spectrally efficient, and really sustainability being the political driver for 6G. What we saw in 5G was prime ministers standing up and saying how this is going to change the planet. You know, the UK prime minister did that, saying that the UK was going to be the first to deploy 5G in the world. I don't know who advised him to say that. He lost his job just afterwards, by the way, but it wasn't because of 5G. It was because of Brexit. But nevertheless, the point is made that it's all becoming very political now. And I think when we look towards 6G, it's all going to be about sustainability and you know, doing an awful lot more for a lot less. But if you want some examples of, you know, some of the use cases, things like holograms, reflective services, smart surfaces, you know, where you're looking at capabilities which really aren't going to be capable with 5G new radio. I suspect that we will have a whole new radio design in 6G. This is what the universities are currently investigating. If you look at it just from a European point of view, it's like 700 million on the table for research into 6G. Again, I've got a slide which shows all the research budgets globally for 6G already, and it's masses of money being invested, which I think is, you know, indicative that it's going to happen. The big question is, you know, exactly when is it? Is it going to be 2026, 2028, 2030, and what will be the real big parameters? And at the moment, I think that will really depend on how successful the research projects are. Terahertz communications is pretty much a given. So we know that if we want to do more for less, we're going to have to go an awful lot higher in frequency. So at the moment, we're stopping at 100 gigahertz for 5G. You're really going to be going up to 300 gigahertz spectrum for 6G. We're just sort of starting to understand how that behaves, or you know, how you can use that sort of spectrum. But watch this space. I mean, there's an awful lot happening on 6G.
Okay, thanks. I think we have a question from Mr. Imadeldin El Tahir. So can you open the microphone, please?
Yes, thank you for giving me this chance. I would like to ask how we can integrate and link the 5G technology with the existing technology, especially in oil and gas, and specifically for offshore operation. How we can link the existing technology with the new technology, the 5G.
This was a question for me, I assume.
Yes.
So thank you very much for the question. I think it's a very good one. I'm not such a big expert in oil and gas, but I know that there's a lot of power link equipment in oil and gas installations. So the question really is, what are the challenges with oil and gas today that cannot be solved with the existing technology there? And I think one thing that's obvious is that we start to see a lot more cellular coverage for the oil and gas industry. So it's if you look at the oil rigs, there's of course a need also there to have cellular communication for person communication, but also when you start to digitalize your services. We also see that a lot of the oil and gas installations today, so if you look at the oil and gas pipelines, quite often they have dedicated private radio networks, either APCO P25 or TETRA. So these are really voice communication networks. But as you start to digitalize operations, you need more data communication. So I think also for the oil and gas installations, you will see this migration from the like the private radio networks, such as TETRA and APCO P25, onto cellular technologies that gives you a lot more data communication capabilities in order to support the digitalization of the industry.
I could add a little bit to that with regards the transition, because it's a very good question. You know, if you have an installed base and you're trying to migrate from one technology to another, you know, it's inconceivable that one day you'll turn one system off and the next day you'll turn the new system on. And this is exactly the dilemma that the public safety community had with TETRA. They are moving from TETRA towards 5G because TETRA is narrowband and they want broadband. And that same technology is widely used in the exploration oil and gas industry. So we specified an interworking profile, which actually enables calls to start in a TETRA network and terminate in a 5G network and vice versa. So it's quite possible to have these interworking scenarios. We say we've done it for public safety. If there are other radio systems beyond TETRA and P25, which we've already done, then that is possible to have that scenario. But I think it's a question we will get from many communities. You know, how do you transition from one technology to the next? Also, related to that question, we have a study ongoing in the maritime sector, which again is interesting because the maritime guys are saying, well, we have too many radio systems. We want to have one system where we can integrate everything together in a port. So if you look through how a port operates, you have ships coming in and out of ports. You've got, you have pilots who are going out to escort the ships. You have traffic. You've got freight being unloaded on and off of ships. You've got asset tracking, and they're looking at having like a consolidated approach using one system where you can then have shared big data streams, which can become very valuable. A good example, if you want to have a look at that, is the Port of Southampton in the UK, who have just launched their, they've just announced that they are building a 5G port in Southampton, where they will integrate all of these services onto one platform. Interestingly, it will be a non-public or a private network, as Jens would say, but it's being operated by a public network operator. So it's a good example of many things, actually, the Port of Southampton.
Okay, we have a question from Mr. Ahmed Mashani.
Yes, thank you, gents, for the very interesting information about the 5G and future 6G. My question is like, I have like a twofold question. The first one about the infrastructure that we need to have in place. I mean, obviously, when we say like wiring, it will be less, but I mean, overall, to have that infrastructure, I believe that repeaters have to be more. I think we need more infrastructure. That's my understanding for 5G to work, so that we get that kind of repeaters or kind of towers that very dense. I mean, in the area to have full coverage or strong coverage that we're looking for. That's the first question about the infrastructure. The second question about is there any challenges in terms of health licenses? Because I believe that being told that probably there is a hazard on health due to this the waves of the signals. Yeah. Is there any challenge that it might be restricted or there is no, like it's just a rumor or something? Because I thought there might be some health effect on the towers or the signals that related to 5G, 6G. Yeah, that's my question.
I will let you go first, Adrian.
On which part? On the health part?
You can take both. I think you have the answer to both of them.
No, you go first, Jens. Go on.
Okay. Well, I will leave the health part then for now. So when you of course when you want to use 5G services in your factory or your process facility or your port or mine or oil and gas installation, you need to have 5G coverage. And then there's a choice whether you want to have, do you want to own the infrastructure yourself, or would you like to rely on a public operator? And of course, if you rely on a public operator, then the investment to get started is small. You just need to find an operator that has coverage in your area, including indoor coverage. But on the other hand, for many organizations, it's important to own the infrastructure yourself. So this is the case for some manufacturing companies, because the communication system is so mission critical to the factory business that you want to have control over your own private 5G network. And also for some other installations, like we have discussed previously, the emergency service, there's oil and gas. Sometimes there's security aspects. That means that you want to own your own private network. So if you want to own your own private network, then of course you need to purchase the base stations and the servers that you have in the core network and so on. And then you have the choice whether you should purchase all this equipment yourself and establish your own organization to operate the network, or if you want to go to somebody who's an expert in operating these networks. So for example, the established mobile operators like Adrian mentioned for the Port of Southampton, or some of the more, there's a number of specialty operators emerging that cater only for smaller networks. So this is a choice that you need to make as an organization. So one, do I want to have my own infrastructure? This is the first question. And secondly, if you want your own infrastructure, who should operate it? Is it in-house operation, or is it somebody externally that should operate the network?
Okay, and shall I take the health question then? Which again is a very frequently asked question about 5G and health. And you know, I'm firmly of the view that you shouldn't let telecom engineers set standards or limits for health, because it's not what we do. It's outside of the scope of both the organisations I represent, and we look to the medical profession, the World Health Organization, to set the safety limits, and we should not try and influence those limits as engineers. I think that will be entirely wrong. What we have to do as engineers is take those safety limits and make sure that system design and implementation fits well within those safety limits. And I think it gets very confusing if we try and do their job and they try and do our job. So I'm a firm believer in you know, letting the health organisations set the health limits, and as engineers we have to work within those limits. What I would say though is that where we see sort of public protest about installation of 5G masts and things. There have been a lot of independent studies, some funded by governments, to actually look to see whether or not the implementations do meet the safety guidelines. And in the majority of cases, they don't just meet those guidelines, they're orders of magnitude inside those guidelines. Moreover, as you see system design moving away from very high power stations on top of hills, we find now that we're seeing much smaller inside factory environments, and so the power will be significantly reduced.
A ver, hola, hola.
Catherine is muted.
Adrian, can you unmute yourself?
Yes.
Okay, thank you. There was a mistake here.
Did I get my message across?
I think the last part not.
Okay, well, I think I've said enough.
Okay.
Okay, clear from my side. Thank you.
More questions? I have a question for you, Adrian. You mentioned about the non-terrestrial networks. I think that might be, just would like to confirm that that could be a good application for long pipelines or long gas lines that in the oil and gas field and the gas sector is very common.
Yeah, very much so. You know, anywhere where it's hard to provide terrestrial coverage, then the non-terrestrial access will be an opportunity. Where non-terrestrial could be a satellite, it could be a high altitude platform, it could be a tethered balloon, it could be a drone, of course, and we've done significant studies into the use of drones providing 5G capability. So in fact, a very interesting example I thought was in Japan, where they have many islands, and the drones will be used to deliver parcels out to the islands, grocery deliveries, because it's so much cheaper to do that by a 5G controlled drone than it is to take a ship out there. So, you know, these sort of things start to become quite interesting. So the non-terrestrial component will sort of manifest itself in many ways, but certainly exploration and, you know, management of oil pipelines, yes, absolutely.
Okay, thanks. Okay, so we're almost in the hour. So do we have any final question? All right, then. I just want to thank you to Jens and Adrian for these magnificent presentations. I think for us in the process control area, this is something new. This is something that is exciting. I know many plants that are still running in cables. So even though there's digital communications, especially sectors like industry like oil and gas are very conservative on this, but you know, 5G and all these technologies are coming very quickly, and I'm sure they will change a lot the way we do things in the future. So not only in our mobile phones, which is something that we always think of, but also in the industry. So thank you very much to all of you, especially to the presenters, and thank you all for coming and attending. As I mentioned, this presentation and the recording will be shared with all the ISA sections, as well as ISA Spain participants in our members area, in our website. And I hope this is the first one of other webinars that we organized in the district level. So thank you very much to all of you, and hope you have a good evening.
Thank you, Francisco.
Yeah, thank you, Francisco, and thank you everybody for listening.
Bye-bye.
Thank you.
Thank you very much.